Have you ever wondered how tornadoes are born? These swirling giants are among the most awe-inspiring and destructive forces on our planet, capturing our imagination and at times our deepest fears. I'm about to take you right to the heart of nature's most dramatic show. Tornadoes are not just random acts of chaos, they are the result of a fascinating and complex dance of atmospheric conditions, each playing a crucial role in their creation. It all begins on a warm, humid day. Picture the American Midwest, where tornadoes love to make their grand entrance. This region, often called Tornado Alley, is famous for its flat landscapes and unique weather patterns that set the stage for these powerful storms. The sun heats the ground, warming the air right above it. As the day goes on, the land absorbs more and more energy, turning the surface into a giant heat engine. That hot air wants to rise, but there's a catch. Above it sits a layer of cooler, drier air. This creates a kind of invisible lid, trapping the warm air below and building up energy, like a pressure cooker waiting to blow. This is the perfect recipe for chaos. When the balance finally tips, all that pent-up energy is released in a sudden explosive burst. Now throw in a strong wind. These winds sweep across the plains, sometimes traveling for hundreds of miles, carrying with them the seeds of a potential disaster. Not just any breeze, mind you, but winds that change speed and direction as you go higher up. At the surface, the wind might be gentle, but higher up, it can roar in from a completely different direction. That's called wind shear, and it's crucial. Wind shear is the secret ingredient that gives tornadoes their spin, twisting the air into invisible tubes of rotation. Imagine twisting a rope between your hands. That's what the wind does to the air, making it spin horizontally, like a barrel rolling along the ground. This rolling motion is invisible at first, but it's the foundation of every tornado. But tornadoes don't happen unless that spinning air gets a lift. Something needs to tip that rolling tube of air upright, turning it from a hidden force into a visible, towering threat. That's where thunderstorms come in, specifically the mighty supercell. Supercells are the kings of thunderstorms, with rotating updrafts that can reach heights of over 50,000 feet. These towering clouds have powerful updrafts, columns of air shooting upward like invisible elevators. The updrafts are so strong they can lift entire columns of spinning air high into the sky. When one of those updrafts tilts the rolling air upright, it creates a column of spinning wind. This is the moment when the storm's energy and the atmosphere's rotation combine, setting the stage for a tornado. This is what meteorologists call a mesocyclone. It's a massive, rotating storm within a storm, and it's the birthplace of most powerful tornadoes. Inside that storm, air rushes in and up, tightening the rotation. The faster the air spins, the more intense the storm becomes, drawing in even more energy from the surrounding atmosphere. Think of an ice skater pulling in their arms to spin faster. The same principle applies here. As the spinning column narrows, it speeds up dramatically, concentrating its power. If conditions are just right, with enough moisture, instability, and wind shear, that spinning column narrows and stretches downward from the cloud. The funnel cloud forms, reaching toward the earth like a finger of the storm itself. Suddenly, a tornado is born. The connection between cloud and ground is made, and the full force of the storm is unleashed. Once on the ground, tornadoes can last minutes or hours, carving paths of destruction or dancing harmlessly across empty fields. Some tornadoes travel for miles, while others vanish almost as quickly as they appear. Each one is unique. Some are little more than dust devils, others are violent monsters with winds over 300 miles per hour. The strongest tornadoes can level entire neighborhoods, while weaker ones might only stir up dust and debris. Meteorologists are constantly studying these storms using radar, satellites, and even daring storm chasers, all to better understand and maybe one day predict these incredible forces of nature. Their research helps save lives, giving communities precious minutes to seek shelter when a tornado is on the way. So the next time you see dramatic footage of a tornado, remember the delicate balance of heat, moisture, and wind that brought it to life. Behind every twister is a story of science, energy, and the relentless power of our planet's atmosphere. Nature, it seems, writes some of the most thrilling stories we'll ever witness. And tornadoes, with their raw power and beauty, remind us just how dynamic and unpredictable our world can be.